Yes, sir.
Pratik, yes, sir. Okay.
Yes,
Nikita,
sir.
okay. One more candidate. I think Sate is there, na? Sate, are you there? Okay, very good. So who is going to start first?
Yes, sir.
Pratik, you want to start?
Yes, sir.
Okay, please. Just start your presentation, then you can present it.
Screen is visible, sir.
Yes, it is visible. Just start PPT. Presentation is not visible. Screen is visible. Okay. Make it full screen. Good.
So let's start with our today's topic, implementation of FIR and IIR filter. So we know the types of filter. There are two types, analog filters and digital filters. In analog filter, there are four types: low pass filter, high pass filter, band pass filter, and band stop filter. In digital filter, there are two types: FIR and IR. FIR means finite impulse response, and IR means infinite impulse response. So, in this slide, um, FIR versus IR. There are two classes we already studied: FIR and IR. The term impulse response refers to the appearance of the filter in the time domain. Filters typically have a broad frequency responses which correspond to short duration pulses in the time domain as shown in figure. This graph shows the low pass filter frequency domain, this is left side, and time domain, this is right side. Uh, so in this slide there is an equation of a FIR and IR filter. This is equation for a FIR filter. Y of n is equal to summation k equal to 0 to n a of k into x of n minus k. And this is equation for IR filter equation. Y of n is equal to summation k equal to 0 to n a of k into x of n minus k plus summation j equal to 0 to p b of j into y of n minus j. This is called a output used recursively. Because in IR filter system there is a one feedback is present, hence it is called a uh, recursive function. In this for this equation, where x of n is the input, that is x of 0, x of 1, x of 2, up to x of n, and x of a of k is the filter is represented by the series labeled a for a FIR filter and a and b for IR filter. For IR filter, n and p are the number of terms in the filter respectively, which is also referred to as the filter order or number of taps. For example, if a FIR filter is performed from k of 0 to k of n, y of n is called output, that is y of 0, y of n, and up to y of n. As earlier I said, the mathematical difference between IR and FIR in implementation is that the IR filter uses some of the filter output as an input, means feedback. This makes the IR filter as a recursive function. This is a difference between IR and FIR filter using these 3 points: computational speed, fast to low order, and in FIR, slow to high order. Phase delay in IR not constant, and in FIR constant. Stability for IR sometimes is stable, and FIR it always stable. सो आपण सगळे जाण आपल्या सगळ्यांना माहितीच आहे लहानपणी आपण एक गोष्ट ऐकली होती कासव आणि सशाची तर युझिंग दिस एक्झाम्पल वी आर we are explaining this point. An IR filter has an advantage that for a similar filter roll-off as a FIR, a lower order or number of terms can be used. This means that less computational are needed to achieve the same result. Means IR in IR there is a less number of computation is required for getting the result. But FIR there is no such case. So making the IR faster computationally. However, an IR has non-linear phase and stability issues. It is a bit like the fable of the tortoise and hare. As I said, this is a example of story of tortoise and rabbit. A fire filter is like the tortoise. Means a fire filter is compared to tortoise, as tortoise is slow, beginning slow, but it achieves success by winning the race. So a fire filter is like tortoise in the race, slow and steady, and always finishes his race or whatever is the result. The hare is like the IR filter, is very fast at earlier, but sometimes crashes and does not complete the race. This is the fire implementation technique. An equation of examination of the equation will show the computation of y of n involves only multiplications, additions, subtractions, and delays. This is extra information I have covered. Delays. An IR filter has an unequal delay at different frequencies, while an FIR has a consistent delay at every frequency. For stability, due to its construction, an IR filter can sometimes be unstable and not be able to compute or applied to the data. The FIR filter formulation is always stable. We studied in the last uh, that comparison table. Thus, next point is thus to implement a filter, we need the following basic components: memory RAM to store present and past input samples, that is the x of n and x of n minus scale. Memory RAM or ROM for storing filter coefficient, the h of k. Multiplier SW or SW. Next adder or ALU. This component together with means of controlling them constitute the digital filter. The if the input source is analog means in this diagram you can see if input x of t signal is analog, then DAC means digital to analog converter is required. This shows in diagram. If the output is analog means this output y of t is analog, then ADC means analog to digital converter with sample and hold is required. The structure of real-time filter has the following structure. This diagram shows the real-time filter. This is some of FIR filter methods. Ratio has the lowest amount of ripple in the stop band, but widest the transition band. Hamming, narrow transition zone, smaller ripple than Hanning, developed by Richard Hamming, who was a member of the Manhattan Project. Sir, I am audible?
Yes, yes, you are audible. You can go ahead.
Kaiser, developed by James Kaiser at Bell Laboratories. The Kaiser window has small amplitude ripple in stop zone. Only the wide transition width Chebyshev has lower amplitude ripple, Hanning, the narrowest transition band, but large ripple in stop band. Rectangular, largest amount of ripple lobes, even if affects passband. And this is IR filter methods. Attributes of the different IR filter method. First, Butterworth. Flat response in both the pass and stop band, but has a wide transition zone. First described by British physicist Stephen Butterworth in 1930. Second, inverse Chebyshev. Flat in the passband with a narrower transition width than the Butterworth filter, but has a ripple in the stop band. If ripple in the stop band is not a problem, might be preferred for a given application over the Butterworth filter. Chebyshev can have a ripple in the passband but has a steeper roll-off than an inverse Chebyshev. This Password. Narrow transition zone ripple in both stop and pass bands, sometimes called an elliptic filter. Basal. Sloping amplitude in both the pass and stop band with a very wide transition zone. The delay versus frequency in the filter is the flattest in this list. The basal filter was named for Friedrich Basel, 1784 to 1846, a German mathematician. So this is the last point, difference between the FIR digital filter and IR digital filter. Um, First difference is finite duration unit sample. H of n equal to 0 for n less than 0 and n greater than m. This is as the name indicates, infinite duration unit. H of n is equal to 0 for n less than 0. That is 0 to infinity. FIR system are non-recursive. As I earlier said, this is feedback is not present in the FIR system, and if in IR system feedback is present, so it is recursive. The equation we see in the earlier slide. A FIR system has limited or finite memory requirements, and in IR system requires infinite memory. A FIR filter always stable, and stability cannot be always guaranteed in the IR filter. In FIR digital filter, exactly linear phase response, and it is non-linear phase. In a FIR filter, effect of using finite whirlwind to implement filter, noise and quantization errors are less severe in the FIR than in IR, and this is not possible in a FIR because no analog put. In the FIR, all zero filters, and in IR, poles as well as zeros are present. This is a example in for FIR, and this is for IR. So thank you so
Okay.
much.
Okay, very good. Any questions you want to ask from the students? If anybody has the questions, please ask. Or else you can give the comment also. Anyone want to share anything?
Nice one.
Yes? Who is that? Yes, anybody want to comment on that? कोणी तर म्हटलं नाईस वन. नाव सांगा की बाबा, चांगला वाटतंय मला. जर तुम्ही बोलला तर मला खूप खुशी होते. पवन
Mangesh sir, Mangesh.
मंगेश म्हटलं का? ओके, व्हेरी गुड. ओके, एनीबडी एल्स? Still anyone wants?
Sir, I like that comparison that
Yeah,
FR filter is compared with tortoise and
yes.
IR is compared with hair.
Yeah, that's what like something special he has done in that part. Good example he has taken. Okay, very good. Who else again? आणि कोणाला काय म्हणायचं? पॉझिटिव्ह सांगा असं काय नाही. पॉझिटिव्ह पण सांगू शकता किंवा काय तुम्हाला वाटत काय की बाबा असं सांगितलं तर बरं झालं असतं असं पण सांगू शकता तुम्ही. So we are all here to learn the things and accept the things. Still anybody? एनीवन वॉन्ट टू स्पीक समथिंग? प्लीज बोलायला शिका तुम्ही. बोललं तरच, बोलणाऱ्याचं सोनं एक माटी विकतंय, नाही बोलणाऱ्याचं सोनं पण विकायचं मुश्किल आहे. आता शक्यतो सोनं घ्यायचं अवघडच आहे, खूप महाग झालंय. Yes, anyone want to speak? Okay, from my side, the presentation was good. So what he has covered like all overall things. He has taken like basic things of FIR, IIR, what all we have discussed. He has given a very nice example, as rightly mentioned by Ketke again. And okay, overall he has covered like how the main factors for the implementation technique is what we require is, as already we have seen, that block diagram. That is the block diagram for DSP. While we are starting the chapter, or we are starting our subject, we have discussed about that block diagram. Yes or no? Hai ka lakshat konala te block diagram? Block diagram of DSP we have discussed. केला ना डिस्कस आम्ही?
Yes, sir.
Yes,
ठीक
sir.
आहे ना?
Yes,
So
sir.
that same block diagram itself is like a implementation of anything. So for even for FIR आणि IR मध्ये फक्त डिफरन्स काय येणार तुमचा इथं? FIR requires only numerator part, and IR requires both numerator as well as denominator part. So which he has explained you very nicely, like that IR system requires the feedback and all again. Right? So that will be the only equation will get changed. So rest all thing will remain same again. Good. प्रतीक, आणि एक काय म्हणायचं मला याच्यामध्ये, थोडं प्रेझेंटेशन मध्ये थोडं करेक्शन्स सांगतो मी तुम्हाला. सो वाईल प्रेझेंटिंग द थिंग्स, वी कॅनॉट रीड द पीपीटी. सो व्हॉट इज देअर इन द सेंटेन्स, राईट? अँड आणि तिथं काय करायला आपल्याला एक्सपेक्टेड काय आहे की चांगलं प्रेझेंटेशन करायचं म्हणजे, सो वी शुड कीप ओनली लाईक बुलेट पॉइंट्स, आणि त्याच्यावरती आम्हाला एक्सप्लेन करायचं सवय लावायचा आहे. ठीक आहे?
ओके सर.
मग हे थोडं इम्प्रूव्ह केलं तर खूपच छान होईल तुमचं प्रेझेंटेशन, आणि शक्यतो ते एक्सपेक्टेड आहे. ओके,
Yes.
राईट, गुड, ओव्हरऑल इज गुड.
Thank you, sir, for giving me this opportunity.
Yes, thank you very much for your accepting this presentation, for doing the presentation. Okay, we'll go to the next candidate. Who is going to present? Nikita or Sate?
Sir, can I?
Yeah, you can start.
Sir, I have not prepared PPT, but
Okay.
I write some notes.
Okay, with notes you want to present it. No problem. Go ahead.
Okay. Good afternoon, all of you. First of all,
Can you start your presentation? So that you want to know, show the notes, or ऐसे ही बोलना है
sir,
आपको?
no, I don't want to show notes because
Okay.
it's so
ओके, थोड़ा अच्छा रहता था नोट्स दिखा के अगर बताते तो.
नाही सर, मी त्या घाण म्हणजे माझ्या अक्षरात काढल्यात. फक्त मी समजलं ते सांगेन, प्रेझेंट करीन.
ओके, ठीक आहे, नो प्रॉब्लेम, स्टार्ट.
First of all, FIR filter means finite impulse response. In second year, we have studied multiple filters such as low pass, band pass, high pass, and band neglected. In
Band
FIR
rejected,
filter,
ना?
rejected. Sorry.
Okay. Okay.
So in FIR filters, FIR filter means filter whose impulse response is for finite duration. At particular time, its impulse response is there, so it is called as finite duration, and it is settled to 0 in finite time, so it is called as finite impulse response. We can say that finite impulse response is better than IIR filter because it is easy to design and easy to sample.
Okay.
Or easy to implement.
Okay.
We can use FIR filter in digital communication in intermediate frequency stage of receiving. Hello, sir.
Yes, yes, you continue, madam.
So we can implement the FIR filter by using hello.
हाँ बोला madam. Your voice is audible to all. Keep continue.
Okay. The basic algorithm for FIR filter implementation is put the input sample into a delay line, then multiply each sample in delay line by corresponding coefficient and accumulate the results.
Okay.
Third step is shift the delay line by 1 to make room for the next input signal.
Okay.
Then equation for FIR filter is y of n is equal to summation n to k of 0 to n a of k x of n minus k, and for IIR filter, okay, first of all, IIR filter means its full form is infinite impulse response. It is also called as a recursive filter or recursive filter because it uses a feedback such as IIR filter output is depend on the current and previous input and previous output. So it is having a feedback. So it is called as a recursive filter.
Okay.
IIR filter we can implement by convolving input signal with digital filter impulse response.
Okay.
Digital filters means it is a system that operates or perform a mathematical operation in a sample. And IIR filter equation is just similar. Y of n is equal to summation k of 0 to n a of k x of n minus k plus b of j y of n minus j.
Okay. Yes. Have you finished?
Yes,
Nikita?
sir.
Okay.
Yes, sir.
Okay. Thanks for your effort. At least you have tried something to explain the difference, definition of FIR and definition of IIR filter. Good. Thanks. Tried for good effort you have done. तो notes वगैरह prepare किया है उसका. But the thing is that whenever you have gotten chance, show best. That's my suggestion to you. Right. So
Okay, sir.
While giving an opportunity or whenever we are getting an opportunity, we should not come up with any reasons. We will try our level best to showcase ourselves. Right. So that should happen there. जब मौका मिलता है तो ऐसा छा जाना चाहिए, वैसा ऑप्शन होना चाहिए वहां पे. Okay. Anyway, you have tried something good. No problem. Next, I will move towards Ankita.
Yes, sir.
हाँ madam, you please. Have you prepared presentation?
सर फक्त FIR साठीच केलंय.
ठीक आहे. जे काय प्रेझेंटेशन केलंय का तुम्ही तयार?
नोट्स आहेत सर, प्रेझेंट करू का?
हो करा की.
First difference between FIR filters and IIR filters. FIR stands for finite impulse response filter and IIR stands for infinite impulse response filter. Hello, sir.
Okay. Continue.
Hello.
हाँ मैडम.
FIR filter has finite duration unit sample response. IIR filter has finite duration unit sample
थोडं
response.
अजून थोडं जवळ
Unit
धरताय का मॅडम? थोडं क्लिअर दिसत नाही तुमचं नोटबुक. Is it visible to all? Are you able to see what she has written? Can anyone give me the response?
येस सर आता दिसते.
आता दिसतंय. Okay.
Yes, sir.
Now it's okay, madam.
Nature of
Please go ahead.
FIR filter is non-recursive. Nature of IIR filter is recursive. Feedback is
Okay.
absent in FIR. Feedback is present in IIR filter. FIR is more stable. IIR is less stable. Sensitivity is less in FIR filter. Sensitivity is more comparatively in IIR filter.
Okay.
Implementation of FIR filter. And FIR filter can be easily implemented using just 3 digital hardware elements: unit delay, multiplier, and adder.
Okay. Very good.
Unit delay simply update its output once per simple period using the value of the input as its new output value in the convolution sum. Y of n is equal to summation of m equal to 0 to m, capital M, h of m into x of n minus m. Here y of n is output, h of m is impulse response, and x of n minus m is delayed input.
Okay.
Here this is diagram for stepped delay line implementation of FIR filter. In this diagram, x of n is the input, h of n is the h of 0, h of 1, h of 2, and h of m. It is an impulse response.
Okay.
In this diagram, x of n multiply with h of 0. Then in the triangular boxes denote multipliers that multiply by a constant h of m. The circle denotes adder. The above circle denotes adder. And y of n is the output.
Okay.
IIR filter implementation. In IIR filter are used in many digital signal processing applications. Despite the fact they do not have linear phase, the main advantages of compared to FIR filters in the fact to have a smaller number of coefficients to achieve the same filtering performance in the frequency domain. IIR filter can be represented using the difference equation and the corresponding transfer function in the z domain. Y of n is equal to summation of I equal to 0 to n di into x of n minus I minus summation of I equal to 1 to n ai into y of n minus I. H of z is equal to d0 plus d1 into z inverse plus up to d of n z raised to minus n divided by 1 plus a1 into z inverse plus up to a n into z raised to minus n.
Okay.
Thank you, sir.
Okay. Good. Madam, the things which you have explained, like this with the block diagram, na, I think they are coming under IR and FIR filter realization part, and that we are going to discuss in the next chapter again. That is realization of structures in the 7th unit is there. So that we will repeat again once again. But very good. You have tried, at least you have made a notes of that part. Good. Whether you have taken help of book or Google.
नो सर, गुगल वरती सर्च केलं सर.
Google बाबावर सर्च केले का? ठीक आहे. Okay, good try. चलो. Anything else? Anyone want to say something about Nikita and Ankita? Nikita, Ankita, combination चांगला झालाय की आज? Yes? किसी को कुछ बोलना है? काय suggestions, काय plus points? If anyone wants to express, please express it. कोणीतरी बोला काय तर. त्यांचे क्लोज मित्र कोण आहेत? अंकिता,
येस सर.
तुमचे क्लोज मित्र कोण आहेत?
जागृती आणि मंजू.
जागृती आहेत का?
हा यस सर.
जागृती, तुमच्या मित्राबद्दल तुम्हाला बोलायचं आहे आता. त्यांचे पॉझिटिव्ह पॉइंट्स आणि निगेटिव्ह पॉइंट दोन्ही बोलायचं आहे. बोला.
She has explained very nicely, sir.
Okay,
And
that is positive point. Can you tell her about the negative points such that she can improve on that part?
no, sir.
असं नसतं ना मॅडम. दोस्त आहे म्हणून मग तुम्हीच खरं बोलू शकतात त्यांना, दुसऱ्याने बोलू शकत नाही. ते तुम्हीच खरं सांगू शकता ना. काहीतरी सजेशन द्या की त्यांना.
The points must be in deep.
ओके, पॉइंट्स मस्ट बी इन डीप. आणि तुमच्यासोबत मी एक सजेशन देतो, ते जरा पीपीटी वगैरे बनवलं असतं तर चांगलं झालं असतं. असं सजेशन असं द्यायचं की त्यांना त्रास पण व्हायला नको आहे ना.
हा.
मग पीपीटी बनवलं असलं तर खूप छान झालं असतं. आणि थोडं मी समजू शकतो, आता कॉलेजमध्ये सिस्टम वगैरे नाहीत, घरी बसून पीपीटी बनवायचं अवघड आहे थोडं. मोबाईल वरती सुद्धा करू शकता आम्ही, वाटतंय ना पीपीटी वगैरे तयार.
नाही सर, पीसी वरच.
मोबाईल वरती करता येतं मॅडम. ट्राय केलाय का?
नाही.
हा, मग कोशिश करायचं आपला. मला वाटतं सगळ्यांकडे आता स्मार्टफोन आहेत. स्मार्टफोन असल्यावरच आम्ही हे सगळं ऑपरेट करू शकतो ना आता. स्मार्टफोन मध्ये सगळे फीचर्स आहेत आता. यू कॅन डू ऑल डॉक्युमेंटेशन विथ द मोबाईल नाव. चलो अंकिता, नो प्रॉब्लेम, व्हेरी गुड. मंजू,
येस सर.
हा तुम्ही काय, यू कॅन यू स्पीक समथिंग ऑन दॅट पार्ट अबाउट अंकिताज प्रेझेंटेशन? हा
हाँ sir, presentation is overall good.
Okay.
Next time try PPT announce. म्हणजे
Okay.
PPT वरती try केलं तर थोडं बेस्ट दिसतं प्रेझेंटेशन आहे ते.
ओके. पीपीटी प्रेझेंटेशन थोडं चांगला दिसतो त्याचा. ठीक आहे.
हा.
आणि काय बोलायचं आहे तुम्हाला?
काय नाही सर.
Okay, hope Ankita has taken these points in positive way. हा अंकिता, तुमच्या मित्रांचं सजेशन पॉझिटिव्हली घेऊन नेक्स्ट टाइमला त्याला इम्प्रूव्ह करायचा. ठीक आहे.
हो सर.
ओके, थँक्यू. निकिता, कुठे गेले?
येस सर.
आहेत का तिथंच? हा, तुमचे कोण
आहे
आहेत?
सर.
ओके, क्लोज फ्रेंड कोण आहेत तुमचे?
सर कोणी पण सांगितलं तरी चालेल मला, सगळेच फ्रेंड्स आहेत.
तसं आहेत कर, त्याच्यामध्ये काय तर आपलं क्लोज पण असतं ना एक, तसे कोण आहेत? सगळे आम्ही फ्रेंडच असतो. हा, क्लोज कोण आहे तुमचं?
सर असं काही नाहीये, सगळेच आहेत. उलट सगळ्यांनी एक एक सांगा.
सगळे नाही की तसं सांगत नसतात ना मॅडम. त्याच्यासाठी तर एक दोघांचं नाव घेतलं तर त्यांनी सांगू शकतात काय तर. सांगा तुम्ही नाव सांगा, कुणाला तुमच्याकडनं अपेक्षा आहे की सांगावं असं म्हणून.
सर A30.
A30 सुप्रिया, अरे देर.
नाही नाही, ऐश्वर्या.
ऐश्वर्या, ओके.
ऐश्वर्या सूर्यपुजारी. ऐश्वर्या सूर्यपुजारी A30.
ओके,
30.
A30 you are talking, right. ऐश्वर्या, are you there?
Yes, sir.
चला, तुमच्या मित्राने तुमचं नाव सजेस्ट केलं. यू हॅव टू स्पीक हर पॉझिटिव्ह पॉइंट्स एज वेल एज निगेटिव्ह पॉइंट्स रिलेटेड टू प्रेझेंटेशन.
तर फक्त ते म्हणजे प्रेझेंटेशन PPT वर करायला पाहिजे.
ओके आणि त्याच्या
सर ऍक्च्युली ना, हे मला असं आवडत नाही. मी समोर असते तर प्रेझेंट केलं असतं छान.
हा ठीक आहे ना मॅडम, द सिच्युएशन, बेस्ड ऑन सिच्युएशन वी हॅव टू डू द थिंग्स नाव. आवडायचं नाही आवडायचं दॅट इज सेकंडरी पार्ट. ठीक आहे ना. आता सिच्युएशन तसं आहे आपलं, मग जसं सिच्युएशन आहे त्याच्यामध्ये आम्ही काय छान करू शकतो ते विचार करायचा. आता मला पण आता ऑनलाईन रोज घेऊन बोर झालाय लेक्चर. सोडायला शक्य आहे का आता? नको वाटतंय मला असं घ्यायला. कधी एकदा जाऊन बोर्डवर फळ्यावर शिकू असं वाटतंय मला आता. मग
तेच बेटर आहे.
हा, ते कधीही बेटर आहे. दॅट्स देर इज नो ऑप्शन फॉर दॅट, आणि दॅट इज ऑलवेज गुड. कसं ते कॉन्सन्ट्रेशन एक वेगळा असतो तिथं, आम्ही फक्त तेच विचार करतो. सो दॅट इज ऑल द डिफरंट थिंग. तर मला
सर
वाटतं
आमचं पण घरी असलं तरी.
हा ना, तेच ना. नाही, दॅट्स क्वाईट नॅचरल मॅडम. बेस्ड ऑन सिच्युएशन कसं रिक्वायरमेंट कसं आहे तसं आपल्याला थोडं बहुत चेंज करावंच लागतं आता. सो इन दॅट वे वी नीड टू थिंक. या, ओके. ऐश्वर्या, स्टिल एनीथिंग यू वांट टू से?
No, sir.
Okay, ठीक आहे, good. Anyway, you have tried something that's I assure you, like that's good thing from your side. But the opinion is that still we can improve on that. There is a scope for all improvement. है ना?
ओके सर.
Okay, no problem. Anyway, good. Along with this, one more task I'm going to give others. So if anybody wishes to take up that in the unit 8, so you have sufficient time. मैंने 7 चैप्टर खत्म करने तक आपको उसका PPT वगैरह तैयार करने के लिए टाइम मिलेगा. So once I complete the 7th chapter, then we will go for the 8th unit. So that is applications of DSP. त्याच्यामध्ये फक्त 3 application आहेत. So like anyone can take one application. If anyone wish to go for that, so willingly if anyone wish, they can come up. नाहीतर मला नाव द्यावं लागतील, दुसरं काय नाही. You just decide. किंवा उद्या सांगितलं तरी चालतंय, उद्या ठरवू आपण त्याचा. ठीक आहे. थिंक ऑन दॅट पार्ट, गो थ्रू द सिलेबस. लाईक ठीक आहे, वन application can be expressed by many people, no problem. So we will take a presentation of that part, right? So hope this, like in FIR and IR implementation, the main thing what are all required is we require the memory, we require that is RAM and ROM, and we require adder, we require multiplier. And as we know that we for implementation of these all things, as that block diagram was shown by the Pratik, that is a very important thing. So there you require like input signal. If it is analog, to convert that into the digital signal, we require the ADC. And that ADC signal, after converting that part, we are applying it to the processor or the sampler, what they have suggested. So then we are applying that to the processor, and the processor gives you the output as a digital thing, that is discrete signal output. So that to convert again into the analog signal, we require DAC. So then again, finally, to understand that, we require the filter circuit. So these are all the main implementation parts, and only the difference you will find in FIR and IIR is the equations which you are using. So equation FIR is non-recursive and IIR is a recursive again. So which has a filter part, like feedback part is present in that part. So you may expect a theory question also on this part. So FIR and IIR, they will ask you like explain about the FIR and IIR implementation technique. That PPT I will send you. What are the things to be written on that part? So this is all about our 6th unit. Okay. So can we summarize here? What are all the things we have discussed in 6th unit? Who will summarize? 6th unit में हमने क्या क्या पढ़े? Let me talk to Prasanna. Prasanna is there? Prasanna, are you there?
Yes, sir.
Can you summarize what are all the things we have discussed in the 6th chapter?
Sir, this time I can't, sir.
Why?
Sir, I came बाहेर आलोय सर मी.
असं कुठं असतंय का? दिस इज नॉट द प्रॉपर वे ना. बघा हे असं असतं ऑनलाईन लेक्चर म्हणजे कोणी बाहेर गेला असतंय, कोणी चालू ठेवून घरचे काम करत असतात. सो द सिरियसनेस इज नॉट देअर. मग नोटबुक वगैरे तुम्ही नोट करत नाहीत का पॉइंट्स वगैरे? मग प्रसन्न,
हा सर.
पॉइंट्स नोट करत नाही का तुम्ही?
हा करतोय सर.
मग आज
नोटबुक नाही आता त्याच्या.
आता नाही, कुठे गेला बाहेर?
इकडे दवाखान्यात आलतो सर.
काय झालंय?
काय नाही सर, डोकं होतं ते चष्म्याचा नंबर बघायला.
आता लेक्चर सोडून जायचं तेवढं इमर्जन्सी होता का?
नाही सर, परत बंद होतंय त्याच्यात.
ठीक आहे. Who is going to okay, let me ask Jagruti. Jagruti,
Yes, sir.
you please summarize what we have discussed in the 6th chapter. कर सकते हैं? जागृती मॅडम,
हा सर.
करा की समरी सांगा.
First, we have seen IIR filter design by impulse invariance.
Okay.
Then examples on that part.
Okay.
IR filter by bilinear transformation. Then steps to design filter by using bilinear transformation.
Okay.
Then examples. Analog low pass filter design and the low pass filter Butterworth filter diagram and explanation.
Okay.
Then poles of transfer function.
Poles of transfer function we have calculated. Okay.
Examples.
Okay.
Then to step to design Butterworth filter.
Okay.
Examples त्यावरती.
Okay. झालं?
And denominator factorized form ते chart.
Okay. Butterworth filter साठी based on order. Okay. So this is all the things we have discussed in unit 6. Actually, I plan to discuss MCQ today, but we have hardly like 5 minutes left over, 5 to 7 minutes. So if anybody is having any questions, you can ask. Doubts वगैरह काय असलं तर विचारू शकते in this chapter or wherever, or any difficulties you are facing. Are you all opening that link what we have given, study material link? Are you referring that part? रेफर करा.
Yes,
प्रॉपर
sir.
ओपन वगैरे होता है ना तो.
Yes, sir.
हां.
Okay.
ओके. एनिथिंग एल्स. आणि काय डिफिकल्टीज वगैरे आहेत का? एनी प्रॉब्लेम यू आर फेसिंग? or any difficulties you are facing to understand the subject? काय अडचणी असल्या तर सांगू शकता तुम्ही. You can express your problems also so that we can overcome. If require, I can go for a revision of that part again if require. Hmm? काहीच प्रॉब्लेम नाही कोणाला? नसेल तर काय प्रॉब्लेम नाही सर म्हणून सांगायचं, मग जरा बरं वाटतंय आम्हाला. शांत बसणं एक असतंय की भरपूर प्रॉब्लेम आहेत शांत बसलं तर. नसेल तर काहीच प्रॉब्लेम नाही. आता कुठलं समजायचं?
नो सर, काही प्रॉब्लेम नाही.
काहीच प्रॉब्लेम नाही. आणि बाकीच्यांना अजून एक 2-3 रेस्पॉन्स येऊ दे की मला जरा. सब्जेक्ट कळतंय ना सांगायचं सगळं? सांगायचं सगळं कळतंय ना? काय अडचण?
Yes.
मला वाटतं असाइनमेंट खूप कमी लोकांनी हे केलेलं आहे. किती जणांनी फिफ्थ असाइनमेंट आय थिंक मोस्ट हार्डली लाईक 4-5 मेंबर्स हॅव सेंट. किती जणांनी पाठवलंय फिफ्थ असाइनमेंट?
21.
Yes, sir.
21.
Yes, sir.
21 8 आणि 5
36.
9.
9 36 आणि 4 जण. बाकीच्यांचं काय अडचण आहे? मग सगळे तुम्हाला ऍट द एंड अल्टिमेटली यू आर गोइंग टू राईट. सगळे एकच रात्री बसून लिहावं लागतं तुम्हाला. बिकॉज ऍट द एंड यू हॅव टू सबमिट ऑल द थिंग्स and I am just noting the things who are all submitting the in time. And ultimately what terms are going to be given based on how you are punctual about the date and all. So last time तुम्ही बघितलं असेल माझ्याकडून काय मार्क्स वगैरे चेंज होणार नाहीत. जे तुम्ही कमवताय तुम्हाला तेवढे मिळतील मार्क्स. It is the way you are there to like how you gain or how you can improve your marks. It is there in your hand. If you are following all the things, you will get 25 out of 24 or 25 also sometimes. But if someone are failing to do all the things, so ultimately your terms are going to be reduced. ठीक है? So okay, with this we will close today, and maybe tomorrow I will discuss on some of the assignment questions of 6th chapter and MCQ, and then we will move ahead. And today's absent numbers are roll number 9, sorry 2, 9 is there. Roll number 9.
No,
Is
sir.
absent, na? Okay. 13. 13 is there. 23, 25, 31, 38, 47, 51, 53, 59, 60, 62, 63 आणि 65. कोण प्रेझेंट आहेत का याच्यामधले? ओके. थँक यू. विल स्टॉप द सेशन हियर. विल कंटिन्यू फर्दर. क्या बोल रहे थे मैडम? नाही आलं. एवढं लवकर येत आहे? परवाचा सबमिट केला ना आम्ही. असं का? हा हा हा. ओके. हा हा. बघू मग, अजून तर काय आलं नाही मला लेटर. असं काय मेल बिल बी काय आलं नाही. ओके. ठीक आहे, चांगला आहे. ओके. ठीक आहे, ठीक आहे. आल्याला मी पाठवतो तुला. लेटर येतं का युनिव्हर्सिटीतून मेल यायला लागले? ओके, ठीक आहे. असं तर काय आलं नाही.